Very warm welcome to this session. In today's session, we are going to discuss the high temperature oxidation resistance of nickel-based superalloys and cobalt-based superalloys. We are going to compare these two things, and we are going to list out what are the primary considerations while selecting materials for aircraft construction. So these are the things we are going to discuss in today's topic. First, how to compare the high temperature oxidation resistance of nickel-based super alloys and cobalt-based super alloys. Okay. And first we should know what is a super alloy. Super alloys are a class of high performance alloys. Super alloys are a class of high performance alloys that exhibit exceptional strength, durability, and resistance to corrosion and oxidation at elevated temperatures. Okay. Once again, we calling that super alloys are a class of high performance alloys that exhibit exceptional strength, durability, and resistance to corrosion and oxidation at elevated temperatures. Elevated temperature, what is the range then? It is about above 600 degrees Celsius. Above 600 degrees Celsius. In Fahrenheit, you can say more than 1100 Fahrenheit. These alloys are designed to withstand the harsh conditions encountered in aerospace and industrial gas turbine applications. This is about the super alloys. There are significance in aircraft manufacturing. Number of things are there, but we will discuss these things later. Now we are moving on to the comparison of high temperature oxidation resistance of nickel-based alloys and cobalt-based super alloys. Okay. When it comes to the high temperature oxidation resistance, nickel-based superalloys and cobalt-based superalloys are having their own strength. Nickel-based superalloys are generally more resistant to oxidation at high temperatures. Okay, nickel-based superalloys are generally more resistant to oxidation at high temperatures, but cobalt-based superalloys can still hold their own, especially with the addition of chromium. We already discussed the chromium content increases. What happens? A high temperature material property. It can goes on increasing. Okay, so this is the thing. And cobalt-based superalloys with chromium content of more than 10% can achieve sufficient oxidation resistance. Cobalt-based superalloys with chromium content of more than 10% can achieve sufficient oxidation resistance and compared to the nickel-based superalloys. And the formation of Cr2O3, it means the chromium oxide film at the surface, it protects the inner metal from further oxidation. Okay. The formation of chromium oxide, that film at the surface, it protects the inner metal from further oxidation. Otherwise, corrosion will be happening. However, at temperatures higher than 1273 Kelvin, that means 600 degrees Celsius, this chromium oxide film can further be oxidized to CrO3, that format, and if it is done, further oxidation happens. What happens? So above 600 degrees Celsius happens, further oxidation will be there. This due to the further oxidation, the features of the protective layer, it will be losing. The protective layer features, it has been lost. It will be lost. That is the further oxidation happens more than 600 degrees Celsius. This is the effect. Okay. So nickel-based superalloys, on the other hand, have a more established reputation for high temperature oxidation resistance with a larger or higher chromium content and for the formation of stable oxide layer also. However, the exact comparison between the two would depend on specific alloy compositions and environmental conditions. Okay, so nickel-based superalloys have a more established reputation at a high temperature oxidation resistance with the higher chromium content and the formation of stable oxide layer. But finally, we can conclude that the exact comparison between the nickel-based superalloys and the cobalt-based superalloys to happen, it can depend on the specific alloy compositions, okay, their compositions and the environmental conditions. Okay, and the comparison between these two, we can have the resistance to oxidation at high temperatures and chromium content increasing. What happens if more than 600 degrees Celsius, then this nickel-based, chromium-based, the nickel-based superalloys, the further oxidation happens. So the protected layer, it will be lost. Those kind of things we have discussed here. In the next thing is, what are the primary considerations while selecting the materials for aircraft construction? First, we should be very clear about the strength to weight ratio. That means we should need a weightless object, but we have more amount of strength. It's called a composite material. So strength to weight ratio will be higher for composite material. That's the thing we want here. Okay, so high strength to low weight to minimize the fuel consumption also. Next, corrosion resistance already discussed. So it is the ability to withstand the environmental conditions and also to reduce the maintenance cost. Then fatigue life is another important consideration. This is the resistance to cyclic loading and stress to ensure long-term durability. The durability is very important parameter for us, so that we need the material to be having fatigue life resistance. Okay, that is for durability. Then we should have the temperature material should have high temperature properties, so that the ability to withstand the extreme temperature in engine and thermal protection systems. And toughness and impact resistance. We know that what is toughness. It is nothing but the ability of material to give resistance for breaking or failure happening. And impact resistance also we should know. Okay, so resistant to damage from impacts or bad strikes and other potential hazards. These are all the things. So toughness and impact resistance, those kind of materials we are in need of. And manufacturability and fabricability. So what are the materials we are in hand, but we should have this machinability so that we can have particular structure to be fabricated. So ease of production, forming, joining to reduce the manufacturing costs. These are all coming under this property. Then cost and availability. Balancing material costs with the performance requirements and ensuring reliable supply chains. Safety and regularity compliance also very much important consideration we should be having. Okay, so it meet strict safety standards and regularity requirements. Then environmental considerations are also very important. Minimizing environmental impact through recyclability, sustainability, and reduced waste also. Maintenance and repair is the main consideration. And resistance to extreme conditions. That means the ability to withstand extreme temperatures, pressures, and other environmental conditions. So those are all things that are very, very important. We have to consider for selecting the materials for aircraft construction. So that's all in for today's topic. We will have another topic in the next class. Thank you for watching this.